Now, whether you realise it or not, so far during the course we've been working with built-in class objects. So for example, if I create a variable called my_list and set this equal to a set of empty square brackets, when we check to see what the type of the variable my_list is, we can see we return list. We also know that we can do things with lists. So if I were to look at the documentation of the variable my_list, which we know is a list object, you can see that the docstring states that we're working with a built-in mutable sequence, i.e. we can change things within this list. If no argument is given, the constructor creates an empty list. Now we also know that if I were to press tab, we get a list of methods that work with this object, i.e. they are methods that allow us to change the list object. Now in object-oriented programming speech, these can be considered as functions that are defined in a list class. But now rather than utilising built-in functionality, we are now going to look at creating our own data structures. And the way we do this is by creating classes of our own. So in this example, we are going to create a data structure that helps us store the information about dogs for our dog daycare center. So we'll first of all create a class called dog. Now notice here that the class named dog begins with an uppercase letter. Now a common convention for naming classes is to follow what is known as Pascal case, and it's a naming convention in which the first letter of each word is capitalized. So for example, if I were to create a class called the dog, it would look something like the with a capital T and then dog with a capital D, and you can see that the first letter of each word is capitalized. After we've named the class, we can put a colon in a very similar way to functions. Now to start with, I'm not going to create any logic of any kind, I'm simply going to put a docstring that states that this is a user-defined object to represent and manage dog data. And then after this docstring, I'm going to put the keyword pass. So you can see here that the body of this dog class consists of two items. We have a docstring to help users understand what this class is used for, and we have the pass keyword. And we use the pass keyword as a placeholder indicating where code will eventually go, but we'll get onto this shortly. We can then run this code cell. Now let's create our first dog. So I can create a variable called my_dog, just like we did when we created a variable called my_list. And this is basically us creating an instance of that specific object. I can then put equals and then call upon the dog class. We can then put dog with a capital D and then a set of parentheses. Now if I take a look at the type of object stored in the variable my_dog, you can see that we get back an object of the dog type. And we'll explain what dunder main dunder means when we discuss packages and modules. Now if I put my_dog and then access the documentation of this class by pressing Shift and then Tab, you can see that my_dog is an object stored at this location in memory, and the docstring tells us that we're working with a user-defined object to represent and manage dog data. And this is obviously coming from our class definition above. Now if I press Tab, you can see that we don't get a list of methods that we can work with like we saw with lists, but that's because we haven't defined them yet. We haven't defined any attributes and we haven't defined any methods to call. But in the next video, we're going to start enriching our dog class so that we can start accessing attributes and methods that we define in our user-defined object called dog. Now we've seen how we can create a new object from a class, which is sometimes called declaring an object. But I'd like to reiterate what this means. So creating a new object from a class is also called instantiating an object. Now we can instantiate a new dog object by typing the name of the class, in this case dog with a capital D, followed by opening and closing parentheses. We can then pass in the two parameters, with the first being name, so we'll set this equal to Bruno, and we'll pass in an age of 4. When we run this code, you can see that we obtain the location in memory where this dog object is stored. So we now have a dog object. Now if you've run the same code on your machine, you will notice that the address you see on your screen is different. So let me create a new dog object, and we'll store this in a variable called my_Bruno. And we'll set this equal to a call on the dog class, so we'll put dog, and inside parentheses we'll put Bruno, and then we'll put the age 4. When I now print out my_Bruno, you can see we get the location in memory. And if I were to put my_Bruno.name and access the name that's associated with this instance of the dog object, you can see we get Bruno. And if I access age, you can see we get 4. Now let's suppose that you also have a dog called Bruno who is 4 years old. If I create a variable called your_Bruno and set this equal to a call on the dog class and pass in Bruno as the first argument and 4 as the second, you can see that when I print your_Bruno, we get a different location in memory where this object is stored. And this is because we've created a completely new instance of the dog object, despite having the same name and the same age. And to prove this, if I put my_Bruno is equal to your_Bruno, you can see that we get false returned. And this makes sense. We could have two dogs which are completely separate objects, so to speak, and they both have the same name Bruno, and they are both 4 years old. So even though your Bruno and my Bruno are both instances of the dog class with the same arguments passed into the parameters, they represent two distinct objects in memory. So hopefully you're starting to observe that one of the biggest advantages of using classes to organize data is that instances are guaranteed to have the attributes that you expect. In this case, we will always need to define a name attribute, and we'd always need to define an age attribute. So we can then use these attributes with confidence, knowing that they will always return a value if ever we call these attributes on the instances that we create. So far, we've seen how we can define instance attributes and call upon instance attributes. And in our current dog class, we've defined an instance attribute called name and an instance attribute called age. In this video, we're going to take a look at what are known as class object attributes. And class attributes are attributes that have the same value for all class instances. Now we can define a class attribute by assigning a value to a variable name outside of the init method. So for example, we know that all dogs form part of the animal kingdom. So we can define a variable outside of our init method called kingdom, and we can set this equal to the string animal. Underneath this class object attribute, you can see we have the init method defined, where we've defined the name attribute and the age attribute. So what will this do? Well, every time we create an instance of the dog class, we can define a name and an age, and these will be specific to that instance of the class. But we'll now be able to call upon a class attribute called kingdom, and it will always state animal, irrespective of the instance of the class that we call it from. So if I type my_dog, and I set this equal to a call on the dog class, so we'll put dog, and in brackets we'll pass in Bruno and the age 4. When I now call upon my_dog and use dot notation, When we press tab, you can see that we have name and age as previously defined as instance attributes, but this time we have an attribute called kingdom. When I call upon the kingdom attribute, you can see that we return animal. If I also define your_dog and set this equal to a dog called Polly, and Polly is 5, you can see that when I call upon your_dog.kingdom, we once again bring back the same string animal. Now class attributes are defined directly beneath the first line of the class name and are indented by 4 spaces, just like we saw when we defined the init method. A class attribute must always be assigned an initial value, and when an instance of the class is created, class attributes are automatically created and assigned to their initial values. In this example, it's the string animal. So we use class attributes to define properties that should have the same value for every class instance, and we use instance attributes for properties that can vary from one instance to another. Now earlier in this section, I introduced the concept of classes and IDs, which give us the ability to associate different tags with a name, but it probably wasn't clear why these were useful. Well, classes and IDs are used by CSS to determine which HTML elements to apply certain styles to, so we give ourselves more control over the styling of a page. But when we're scraping, we can also use them to specify the elements we want to scrape. And let me tell you this, it makes things very, very easy. Now to illustrate this, we'll once again scrape the same summary text as the previous example for continuity. So we can first of all create our GET request and then create an instance of the beautiful soup object. So hopefully no problems here. Now how many lines of code do you think it will take to bring back the paragraph accordingly? Now maybe you'll be surprised to hear that we really only need 2 lines of code. So we'll use the find_all method to search for items by either class or by ID, but for our specific example, because we know this summary text sits within the div container with the ID top news, we can now access the find_all method, so we'll put soup.find_all, and in parentheses we can simply search for where ID equals top news. Now when I run this code cell, we bring back a beautiful soup object known as result set. And somewhere in the middle of this result set is that paragraph that we're after. And the way that we can obtain this paragraph is to simply split this HTML result set by a new line. So if I were to convert this result set firstly into a string, so if I first of all allocate this result set to a variable called a, and then convert a into a string using the built-in string function, then place a dot, if I put split and then pass in \n to denote a new line, you can see that when I run this code cell, our result set is split into a list where each tag and the respective text from this div container that's labeled with an ID top news is split into different elements. And seeing as this isn't a very big result set, if I count through the elements, I can see that this is element 1, we then have the class icon as element 2, element 3 is the body, 4 is the h1 tag, 5 is the p tag, and the text of the p tag is element 6, so it sits at index 5. So just after our split method, we can pass in square brackets and then access index 5. This brings back the text accordingly, but you can see we have some space at the start, and if we just want to get the text in a nicely presented string, we can simply call upon the strip method on this string object, which will remove that white space accordingly. So you can now see that we started by accessing the top news ID, which brought back a result set. We've then split it by new lines to get our respective elements. We've accessed the 6th element, which is where that summary text was sitting, and then we simply called upon the .strip method to tidy up the paragraph. So not only can we use tags to identify specific components of a web page, we can also find specific components based on class name or ID name. In this example we've used ID name, but if you wanted to access a specific class, simply put class underscore equals and then put in your class name. In the next video, we're going to start looking at how we can extract forecast information from the National Weather Service website, which we'll then aim to put into a Pandas data frame ready for analytics. So I'll see you in the next video.